In problem number 1 of lesson 4.3, you're being asked to pair or match something in root form. So A and C and G are roots because of the radical symbol, with rational form. That would be like a third, 2/5, 3, 0.4. And in the table, I've indicated in parentheses how many answers get paired up with A. So A and two other expressions here are equivalent to each other, and for F, for example, it's just 1. So as we talked about in class, the 2 in this problem is the numerator of the fraction, and the 5 is the denominator. So it's x to the 2/5. So that would be answer J. I would recommend putting your answers in as capital letters, because some of these problems, the lowercase letters actually have a special name and value, such as E. And then 2/5, again, I'm indicating there's 2 answers here, so the only other thing we can do with the 2/5 is turn into a decimal number, and hopefully that's the second answer. So 2 divided by 5 is 0.4, which is answer E. Problem B is x to the 2.5, so that means I'm looking for a fraction that's more than 1, and that when I divide the two numbers, I'm going to get 2.5. So I got a 5 on the outside here, I got a 2 here, so this is the numerator, and this is going to be the denominator. So that's more than 1. Here I got a numerator of 1 and a denominator of 3. That's definitely less than 1. So this is the one that has a radical form that is going to be more than 1, and it's going to be 5/2. And 5 divided by 2 is 2.5. So that means G is equivalent to B. They're both 5/2. And I indicated that there's a second one. So again, I've already mentioned the fraction 5/2 a couple times here, and problem D is also another way of writing a rational of 5/2. So D is the other one. So C and D, F, you're looking for one answer, and the remaining. In this problem here, you are writing this in the B to the N form. So again, as mentioned, the numerator is next to the number, which is, or the variable. This is A to the first power, that's the numerator. The 6 is the denominator, so this would be A to the 1/6. I want to turn it from radical or root form into rational form. The only one that's going to be really tricky or trickier here is this one here. This is a numerator of 1 and denominator is 2. And so it's a square root of c to the first. So if I was going to write this as it's from radical form into rational form, it would be c to the 1/2, but they want the base to be in the numerator. So if I move it up into the numerator, as we talked about in the previous chapter, the exponent will change from 1/2 to -1/2. So this final answer is c to the exponent of -1/2. So again, the number on the outside, that's always the radical, that's always the denominator. The number under it or on the outside here, those are always numerators. And we're asking you to write the rational form. Problem 4, we've done some problems like this, and the first comment I've made is you got to change this back into a rational form. So the numerator is 1, the denominator is 6, so it's 1/6. And then we're trying to get an exponent of 1. So it's 1/6 times another fraction that's going to give me a fraction that equals 1. And we've talked about for the last week or so that we do the reciprocal. So 1 times 6 using the denominator and 6 times 1 using the numerator, that's going to give me the fraction of 6/6. And 6 divided by 6 is 1. So I'm going to multiply this expression the 1/6 exponent by a 6, and then we're also using a 6 on the other side. So it ends up being a to the first power on the left side, and then on the right side it'll be 4.2 raised to the 6th power, and we'll get like 5,489 .032 as an approximation. So the first couple of screens here, the problems are basically the same types of problems, with the exception maybe having the exponent on the outside, but the same types of problems we've been doing in class. Problem 4, same thing. Problem 5, same thing here. Problem 9 is asking, is this a shape of a power function, an exponential, or none of these? So a couple days ago I did a video where I asked the question, here are the two kinds of equations, power functions and exponentials. And in exponentials, they take on generally two forms in terms of their shapes. And power functions, the same thing, they generally take on two forms. And so which one is it? Not sure. Go back into the notes. It was a video from this earlier in the week, or in the last week, that is actually one of the first problems in the video. Same thing here. Is it a power function or neither? Or exponential, and the same thing here. In this problem here, we're simplifying. So this goes back to what we talked about from our exponential work. So we have 3 to the 3rd power, because we're multiplying an exponent of 1 here. So it's 3 to the 3rd power. And then we're taking 3 times 3, which is 9. So the answer here is 27x to the 9th. So what the one here's the final answer is a number times a base to an exponent. My number a is 27, my base is x, and my end value is 9. So they want you to simplify these. Now, keep in mind that the exponents, we talked about this, the exponents can be negative. So when you're subtracting these exponents here, you may end up with a negative number, and that's okay. In this form, a negative exponent is okay in this form. So we want an a value. Now, a value could be a whole number, it can be positive, it can be negative. We could have a fraction, like in this case here, we may end up with a fraction, and that's okay for an a value. It just simply means it's not going up as fast. And our exponent, again, our x can be negative. This is a shifting problem, and it asks you to write your answers in the space provided to the left here. So the parabola starts off looking like this. That's our parent function. And so they're asking here is, based on our parent function, what am I doing to move this graph up? What's that equation look like? That's problem B. And what's the equation look like if I want to shift it to the left? So I've given you the two forms here. So is to get a parabola like this, is it the equation on the left or is it the equation on the right? If I'm shifting to the left or right, am I replacing this question mark? If I'm moving the graph again left, right, or up or down, am I replacing this number? Because I'm staying on the x-axis in one case and the y-axis in the other case, that means one of those two numbers is going to be 0 because the x-axis is a 0 value and the y-axis is also a 0 value. So we've done these problems before, and so you can use replace both question marks with numbers, or just the one question mark and understand the other numbers is a 0. So this goes back to chapter 3. Same thing here. Parabolas, which equation is it? The graphs, again, one's being moved to the right and down, the other one's being moved to the left, up, and then being flipped over. So how do I write the equation to flip the graph over? This is our square root graph, and so the parent function looks like this. So I want to move this graph straight down, and I want to move this graph straight to the left, and so which equation am I using? And then replace the question marks with the numbers. If you're struggling with these problems, again, these are review problems from chapter 3, you can always go to Desmos Graphing calculator online and put in y equals x squared, that is the parent function, y equals x squared. and then figure out how to change the equation to get these answers. And this one here is a square root. So I could type in the square root equation, and this is the parent function for the one I drew. And then figure out how to change the question mark values to get the graph to move left, right, up, and down to get to the right place. Same thing here. We're going to move it. The function starts off looking right here. So how do I move it to the left? 2 up 1. How do I move it 1 right, 1 down? And the graph's getting flipped over. So how do I do that? So these are all things from chapter 3. So Desmond's graphing calculator could be a good place to start. And then here is where I'm giving you the equations in Desmos so that you can actually put the numbers in, because the exponent here is no longer 2 but a fraction. So 2 question marks, and we're trying to get the graph to go from the blue graph up to the green, and we're doing that 3 times. And I'm telling you, in the last one there is an a value, so the graph is going up faster than it's supposed to. So I'm leaving these for you to work on, but understand that our work for shifting left and right and shifting up and down hasn't changed. That if there's a number on the outside, that usually is an indication the graph's going up faster. If it's more than 1, if it's a fraction between 0 and 1, that means the graph is going up slower. If it's negative, that means the graph's going down, because we're getting the opposite answers. So spend some time playing with the equations. Part of these lessons is provide you not only a homework but also an opportunity to investigate. If you have individual questions about the problems, let me know. But most of these problems are designed to be reviewed from our chapter 3